So I will just give you a brief introduction to the term chemistry as created by Bill Newman and Larry Principe. Basically alchemy, chemistry and much more, and including scientific laboratory work, spirituality, religion, philosophy, poetry, literature, art, mining, assaying, metal crafts, medicine, pharmacology, economic innovation, entrepreneurship. This is the 20, 30 last years of research on early modern alchemy has been a complete revolution. And when we talk about the work on metals, it's just one aspect of this. So today we perceive them as unconnected, but at that time they were just one thing going together, and alchemy was the glue, the viscera that held this project together. In this lecture I will just talk about alchemy, chemistry and mining. And alchemists, miners and assayers had, and this was, we must establish as the premise for all of this, they had real knowledge about metal extraction and refinement. And in this group of people moving about the European continent, they had the awareness that transmutation was a difficult pursuit, which could be pursued in the setting of the mining industry, but most believed it was possible. We have already heard quite a lot on this, so I will just pass it by. But we need to establish this. Again, we have talked already about the Mercury sulfur theory, a theory grounded in the practical knowledge of smelting and assaying, based in a multi-layered conception of matter. So if we consider this as metals first, metals constitute our sensory reality. That's where we interact with reality. Just as we can interact with chairs, with mirrors, with beautiful sculptures. This is the sensory reality. The sulfur and the mercury is the reality which is accessible through analysis or decomposition. So when things fall apart, metals fall apart, that's sulfur and mercury, which they are made from. And this is something we can get to at the level of laboratory work. And then underneath there, we have earth, water, air, and fire. And these are inaccessible in these schemes. They are a deep underlying reality which just cannot be reached by means of analysis. And this means that, and this is just one scheme of many. There are others as well, like the Paracelsian scheme and the Helmontian scheme. And it's very important to understand that this is a multi-layered image of reality, and this multi-layered image actually describes real physical processes, which can be reached through the various techniques used in the alchemical laboratory. And transmutation, as we have heard already, is achieved by changing the ratio of sulfur and mercury in these metals. So it's not magic. It's not really invoking any deities in the classic Egyptian or any pantheon. This is scientific in a way, or proto-scientific, but we shouldn't reduce it to that, and this is the reason why we must also think of the wider cultural connotations of this alchemical enterprise. And what I will talk about is how 18th century mining chemists gave up on these models. They gave up on them, they left them behind. And what they come up with as an alternative is the concept that metals were simple, unblended, pure chemical substances. That's the end point of analysis. And why did they come up with this? Because they were practical people working in mines, around miners. So metals are the outcome of the production process of a mine. If you have a gold mine, gold is the end product of the mining process. Going deeper into the gold and decomposing it into sulfur and mercury is no point, because sulfur and mercury have no value compared to gold. It's the gold you want. So in the mine process, that's the end point. That's the money-generating product. So stop there. for practical reasons, no reasons to go deeper. Also, in the 18th century, alchemy was suffering from a truly bad reputation. So there's a very good reason for the chemists of the 18th century to say, we're not alchemists, really. We're just chemists, you know. Stop that alchemy stuff. We're not interested. Because then you get rid of the bad reputation of your forebears. However, it's really important also to remember that the stuff that the 18th century chemists did was exactly the same laboratory stuff as the alchemists did. There's a complete correspondence when it comes to the apparatus used, the reagents, the equipment, everything. So it's an absolute continuation of the same tradition, but let's just forget about the past and look at the present. So this is a kind of modernist stance. And here, and this is my argument, which I have proposed for many years now. Some people have started to listen. Is that in this group of people, we find the very first formulations of the modern concept of a chemical element. And it's a conceptual innovation. So, let's look at the traditional metals. We have seen one of these lists before. So we have gold, silver, copper, iron, tin, lead, and mercury. Mercury status is contested whether it's a metal or not, because we have this thing where it's also one of the principles which generate the metals. So therefore, it's not certainly a metal in all schemes that we have, all possible schemes that we have. And then we have the semi-metals discovered since antiquity. And these are antimony, bismuth, arsenic, magnesia. The magnesia, again, is kind of a catch-all category which designated a lot of different things. And then we have zinc. So these kind of start appearing from medieval times. Some of them seem to be discovered in India. Some of them come from the Islamic world. They come to Europe and begin to be integrated into European discourse about metals. They are often not considered true metals. And the distinction, again, is highly practical. If you beat it with a hammer and it breaks, then it's a semi-metal. If you beat it with a hammer and it changes its shape, then it's a true metal. So this is really practical stuff. But you see, all of a sudden, it's not like 7 wonders of the world, 7 seas, 7 planets, 7 metals. We can't talk that way anymore. It's more difficult. It's weird. We have all of a sudden a list of stuff that we cannot really place in these ancient schemes of things. And then we add on discoveries of the first half of the 18th century. So we have cobalt, 1735, nickel, 1751, and platinum, 1752. Platinum was, of course, known to people in the Americas before that, but the first description in chemical terms is 1752, also known to assayers in Mexico already in the 17th century. So you have to have these lists of various things, and now you kind of see that we are kind of slowly approaching the periodic system, aren't we? Already by just listing metals, we have a section of the periodic system here, right? And quite impressive. In the traditional scheme of things, you would have, as I mentioned, 7 planets, you would have 7 metals, you would have 7 seas, you would have 7 of all kinds of things which are natural in this universe in which we live. But we discovered nickel, a completely unknown metal. No one has really described it before. Exactly what does it correspond to? Does it correspond to Neptune, the planet Neptune? Yeah, we could start creating these kinds of correspondences, and contemporary astrologers, yes, they have continued, but everyone else has stopped doing that kind of stuff. So the scheme of conceptualizing things in correspondences breaks down and must be replaced with other conceptual schemes. And I think this quote is absolutely key. There is no danger attending the increasing the number of the metals, astrological influences are now in no repute among the learned, and we have already more metals than planets within our solar system. It would perhaps be more useful to discover more of these metals than idly to lose our time in repeating the numberless experiments which have been made in order to discover the constituent parts of the metals already known. In this persuasion, I have avoided to mention any hypothesis about the principles of metals, the processes of mercurification, and other things of the like nature, with which, to tell the truth, I have never troubled myself. This is high Enlightenment critique of alchemy, proposed by Axel Fredrik Cronstedt in his An Essay Towards a System of Mineralogy. And who is this guy Cronstedt? He is the discoverer of the metal nickel. And so, Cronstedt's essay then, we can perceive it as an outline for the 200 years of future chemistry. So there is no danger attending the increasing the number of the metals, he said in his English translation. Yeah, so what do we do instead? We embark on a program of discovery of new metals. That's what we do. He says that's what we do. And these are soon to be called chemical elements, and to be slightly patriotic, waving the little Swedish flag here in a Swedish ironworks. This is the kind of place where it happened. Up until 1850, 40% of all chemical elements were discovered in Sweden by people connected to the Swedish mining and iron industry. 40%. Yeah, Sweden. Yeah. So, and then we have already more metals than planets within our solar system. Yeah, forget correspondences, forget astrology, forget magic, forget unscientific superstitions. We just cut the link to the past. We shouldn't really lose our time in repeating the numberless experiments which have been made to discover the constituent parts of the metals already known. Forget about going to the deeper layers in the metals. Stay with the product of the mine. Stay with the commodity. Abandon gold making and transmutation. High Enlightenment thought. Avoid hypotheses about the principles of metals. Yeah. Please don't mention transmutation again in polite company of chemists. Don't do that. And this is actually a key point, because if you would have someone wading into a discussion among polite chemists, and he would say, you know, Jabirian alchemy says, then you would know, no, this is not a person who's in our group, right? Forget about it. And yeah, so you see here, I gave you the Swedish original, 1758. We have German translations of this text in 1760, 1770, 1780. We have the French translation in 1771. We have the English translation first appearing in 77 to 72, and then yet more editions of that in 81 and 88. You also have a further Swedish edition, and I think a couple of other languages as well. But I give this also to make my final point of this talk. Most people associate the revolution, the great change in 18th century chemistry, with the innovations of Antoine Laurent Lavoisier. He was born in 1743, Swedish original, 1758. So, says quite clearly all of these things when Lavoisier was still a teenager. Thank you.
Thank you. Did you start by saying that there's been a complete revolution in the research on alchemy in the last years?
Yes, if we think
how and why?
If we think of the last years as the last 30 years or so. And the reason is that with regards in particular to early modern chemistry, we have more or less moved from an interpretation which was the Jungian interpretation, where alchemical symbolisms were considered as symbolisms of the soul and nice images and unconnected to laboratory reality. And now it's been proven beyond all doubt that alchemy actually works. You can take an alchemical treatise not all treatises in all contexts, but you can take many of them and you can decipher them, find the chemicals, do the experiments, and then you will see the results happening up to a certain point. So this is now known and established fact. And 30 years ago, this was completely unknown. So this is the revolution, really. And this is the reason also why replication of experiment has become such a central concern of many scholars.
Yeah. Was the switch from alchemy to chemistry smooth, or did the alchemists fight back?
Yeah, the alchemists fought back, but they didn't really get much traction. And I think it's also a matter of institutional stuff going on. So alchemists continued much business as usual. So you would have royal patronage of alchemists, for example, in Sweden, where Gustav III was patronizing, not patronizing too, but he was giving patronage to alchemists all the way to the 1780s. But so in that traditional context, alchemy just continued as usual, but it never actually, but it was ejected from industrial pursuits, it was ejected from universities, it was ejected from the learned academies, and that's the places where you have the growth in science of this period.
Is there anything important that the early chemists missed out?
Things they lost which alchemy held on to.
Yes, or new knowledge that they hadn't yet acquired. It was a fledgling science.
Yeah, I mean, there was still, I mean, the 18th century saw quite a lot of changes in the chemical tradition, but the stuff that happened in around the turn of the century, 1800, was really important too, because then you would have especially the emergence of organic chemistry, with the realization what living bodies are composed of, and so you would have those things happening, and then you would start doing the synthesis of various chemical substances, leading to the chemical industry. But now we're a bit into the 19th century. Yeah.
Thank you very much, Matthias. We leave the stage.
Hjalmar.